Hello again, everybody. Welcome to the Math Magician's Den. This is the Herm Dog. We are going to talk about the product rule for derivatives today. What is the product rule? Well, when you multiply two functions together, like f of x times g of x, you cannot just take the derivative of f times the derivative of g. That's not correct. What you have to do is you have to take the derivative of the first function times the second function, plus the first function times the derivative of the second function. And let me show you what we're doing here. The first function here would be x squared. The second function, I'm going to try to use different colors here. The second function would be cosine of x. So how do I find the derivative of f of x? Well, what I'm going to do is I'm going to take f prime of x equals, what's the derivative of x squared? It's 2x. And what I need to do is I need to multiply that by the second function, which is cosine of x. Now, the product rule is plus. And we would put x squared this time because that's f of x. And now we're going to multiply by the derivative of cosine, which is negative sine of x. So my derivative is going to be 2x cosine of x minus x squared sine of x. That is how the product rule works. So it's the same kind of thing with the next function. We have 2x times cosine of x. That is two functions of x multiplied together. So how am I going to do my first derivative? Well, I'm going to take the derivative of the first function, which is 2. And I'm going to multiply that by cosine of x, the second function. Product rule is plus. I'm going to take the first function, which is 2x, and I'm going to multiply that by the derivative of cosine, which is negative sine of x. So just for this first term, the derivative would be 2 cosine of x minus 2x sine of x. Now, when I look at that second term, ladies and gentlemen, this is not a product because it's not a function of x times a function of x. This is a constant multiple of sine of x. It is negative 2 times sine. So what we do is we take negative 2 times the derivative of sine, which is cosine. Now, take a look at my derivative. I'm going to have to do some simplifying. Those 2 cosine of x's cancel, and my derivative is negative 2x sine of x. That's the only term that's left after I simplify. Now, g of x. How do I find the derivative of g of x? First of all, I'm going to write g prime of x equals. The derivative of sine is cosine. And then I'm not going to take the derivative of the second part. I'm not going to take the derivative of the cosine of x. Product rule is plus. I don't take the derivative of sine of x this time. I take the derivative of the cosine, which is negative sine of x. So my derivative this time is cosine squared x minus sine squared x, which I think is a totally acceptable question, or answer to this question. But if you look at some of your rules for trig, this is actually 2 cosine, I shouldn't say 2, my bad. Let me erase that 2. This is actually going to come out to be cosine of 2x. That's a double angle formula. So watch out for those double angle formulas when you are working with trigonometry. Sometimes they can pop up. Now, what I have my students do with this next question, I have them do it 2 ways. I have them take the derivative the way it's written. So they're going to have to take the derivative of the first term, or the first factor, which is 3x squared minus 2x, but they leave the second factor alone. Plus, the first factor is x cubed minus x squared times the derivative of the second factor. That is the product rule. Okay? Now, if I were to multiply all of this out, I would get 3x to the fourth plus 3x squared if I distribute, minus 2x cubed minus 2x, and over on this other part, I would get plus 2x to the fourth minus 3x cubed. This is what I get if I distribute. And I come up with 5x to the fourth minus 4x cubed plus 3x squared minus 2x. If I combine all the like terms, this is my derivative. Now, the reason I have my students do it this way first is because I want them to see that the product rule is actually going to work, even if I don't multiply it out. I could multiply this out first and get x to the fifth minus x to the fourth plus x cubed minus x squared. If I take the derivative of this function, I get 5x to the fourth minus 4x cubed plus 3x squared minus 2x. You'll notice in the darker color, I took the product rule to find the derivative because this was a product. In the green, I multiplied out that product first, then I took the derivative, and I got the same exact derivative. So the product rule does work. Now we have another rule for quotients. Again, with the quotient, you don't take the derivative of the top and divide by the derivative of the bottom. That is completely wrong. Don't do it. What we do is we take the derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. And obviously, in this particular case, g of x cannot be 0. That's a very important part of the quotient rule. The g of x on the bottom can't be 0. So let's look at a couple cases here. And I wrote the derivative. Keep moving things here that I don't want to move. I wrote the quotient rule for you at the bottom of the page here, so we've got it handy. Now, if I take the derivative of f prime up here, f prime, or if I find f prime of x, I'm going to take the derivative of the top first, which is 2x. And I am going to multiply that by the bottom, which is 3x plus 5. Now, quotient rule is minus, so I'm going to subtract the top, which is x squared, and I'm going to multiply that by the derivative of the bottom, which is just 3. And this is going to be all over the bottom squared. So if I distribute on the top here, I'm going to get 6x squared minus 3x squared. That gives me 3x squared. If I distribute here, I get plus 10x. And even if I were to cancel out or factor out the x, it's not going to cancel with the bottom. This is your derivative using your quotient rule. Now, the next problem I've shown you here is going to be a little bit more complicated. And if you're not keeping up with me, please feel free to pause the video. What we're going to do here to take our derivative of g of x, I'm going to take the derivative of the top, which is x to the 1/2. And if I write this properly, first of all, x to the 1/2. If I take the derivative of that, I'm going to get 1/2 x to the negative 1/2, which is 1 over 2 radical x. And what I'm going to do is I'm going to multiply that by the bottom, which is x squared minus 11, or minus 1. Quotient rule is subtract. Now I'm going to take the top, which is radical x, and I'm going to multiply that by the derivative of the bottom, which is just 2x. And this is all over the bottom squared. Now that is your derivative. If you have a teacher or you have an instructor that says, hey, you don't need to simplify this, I'm done here. But you're going to see there are some important points to simplifying when you have radicals and when you have derivatives like this. We'll explain that in another future video. But what I'm going to do is I'm going to take the entire top and multiply by that denominator, 2 radical x. I'm going to do the same thing on the bottom. So the bottom here is going to be 2 radical x times x squared minus 1 squared. If I distribute here, I can cancel the 2 radical x and I'm left with x squared minus 1. Minus. If I distribute here, 2 times 2 is 4. Radical x times radical x is an x times that x. I'd end up with an x squared. So I end up with negative 3x squared minus 1 on the top. And I end up with 2 radical x times x squared minus 1 squared on the bottom. And there's my first derivative using my quotient rule. I hope this video has helped. If you like my video, please hit the like button. Feel free to subscribe to my channel. I'll be posting more videos later on.